Alright guys, so today we're going to be talking about something that you're probably pretty familiar with, something that you've used in the past, and that is the relationships that are created when you have two parallel lines that are cut by a transversal. So right here you can see in this picture we've got line N and M that are parallel, and then line T is a transversal because it's going through those two parallel lines. So the first relationship we'll talk about that you're probably familiar with is vertical angles. And vertical angles are created when you have parallel lines cut by transversal. Remember, these are angles that are opposite each other whenever two lines cross. So up here at the top, you've got angle 1 and angle 4. And then you also have angle 2 and angle 3. So we can list those down here at the bottom below. We say angle 1 and angle 2. I'm sorry, not angle 1 and angle 2, angle 1 and angle 4. And we have angle 2 and angle 3. Right, then at the bottom intersection, angle 5 and angle 8 are vertical angles, and angle 6 and angle 7 are vertical angles. Now what's important to understand about vertical angles is that vertical angles are congruent. Remember, that means that they are the same value. So whatever angle 2 is, that's also the value of angle 3. Whatever angle 1 is the value of angle 4. So that's always true for any vertical angles. All right, next we'll talk about is a linear pair. All right, so right here you've got at the top intersection, angle 1 and angle 2 form a linear pair. And also angle 3 and angle 4 form a linear pair. So we can list those right here, angle 1 and angle 2, angle 3 and angle 4. But also, you also have a linear pair formed by angle 1 and angle 3 because they make the line T when you combine them. And then also angle 2 and angle 4 are a linear pair. So we've got to list all four of those, angle 1 and angle 3, and angle 2 and angle 4. Then at the bottom you have the same situation. Angle 5 and 6 are a linear pair, and angle 7 and angle 8 are a linear pair. So we've got to list those two, angle 5 and angle 6, angle 7 and angle 8. And then similar to the top, the angle 6 and angle 8 are a linear pair, and angle 5 and angle 7 make a linear pair. Now, the way these angles always relate to each other is that they always are supplementary, which means they add to 180 degrees. Okay, so linear pair are supplementary, vertical angles are congruent. All of the types of relationships we're going to talk about are one of those two things. They're either going to be congruent or they're going to add up to be 180. It's going to be one of the two. So that's all for linear pair and for vertical angles. We'll go on to the next two relationships. Okay, go ahead and scroll down to your next boxes. All right, so the next one we'll talk about are same side interior angles. All right, same side interior angles are what they sound like. We'll use an abbreviation. Sometimes you'll see SSI. So same side interior angles are angles that are on the same side of the transversal and on the interior of the parallel lines. So if you imagine your parallel lines right here are railroad tracks, the space inside them is the interior of the railroad tracks. That's the interior right there. Any angles that are in there are considered interior angles. All the angles that are on the outside, either way, of the railroad tracks are called exterior angles because they're on the outside or the exterior of the railroad tracks. So when we talk about same side interior, we're talking about all the angles on the interior of the railroad tracks, but that are on the same side of the transversal. So for example, 4 and 6, they're both on the interior, but they're also on the same side of the transversal. And then 3 and 5. So angle 3 and angle 5 are same side interior, and angle 4 and angle 6 are same side interior. Now those are the only two pairs of same side interior that we have. And these, remember we said before that they're either going to be congruent or they're going to be supplemental, one or the other. These are supplemental or supplementary, either way you want to think about it, which means they're going to add to 180. Okay, so any same side interior angles are going to add up to be 180 degrees. All right, so that's all for same side interior. The next kind are alternate exterior. Alternate exterior angles. And these, again, using the terminology we know, exterior means they're on the outside of the railroad tracks. Alternate means they're on alternate sides of the transversal. So not the same side, now the alternate side. So on the exterior, we have angle 1. All right. On the other exterior side, we have 7 and 8. Well, which one is on the alternate side of the transversal? 8 is. 7's over here on the same side with 1, but 8's on the alternate side. So angle 1 and angle 8 are alternate exterior. And then the other pair of alternate exterior are 2 and 7. So those are the two pairs of alternate exterior angles that we have. And alternate exterior angles are always going to be congruent, which means the same, the exact same value. Okay, now let's roll on to the next types that we could see, we could end up having to worry about. So the next one we'll talk about are alternate interior. And again, we know that terminology. Alternate interior. So they're on the interior and they're on alternate sides. So 3 and 6. They're on the interior, but they're on alternate sides of the transversal. And of course the other ones are 5 and 4. So those are your pairs of alternate interior angles, and alternate interior angles are congruent. Okay, they're always going to be equal to the one that they pair up with. All right. I think the very last one we'll talk about are corresponding angles. Okay, and the word corresponding basically just means they're in the same spot. They correspond to each other in the same location. So when you look at the top intersection and the bottom intersection, the corresponding angles are the ones that are in the same location at their respective intersections. So, for example, angle 1 is in the top left, right? If you look at the intersection, angle 1 is in the upper left of that intersection. Well, what's the upper left of the other intersection? Angle 5. So angle 1 and angle 5 are corresponding angles. All right, then we can say angle 2 is in the upper right, angle 6 is in the upper right. So those are corresponding. Angle 3 and angle 7 are corresponding. And then angle 4 and angle 8 are corresponding. Corresponding angles are always congruent to each other. Okay, so as you notice, the ones that we have that are supplemental are just same side interior and linear pairs. The other 4 types are all going to be congruent angles. Okay, so let's just finish this up real quick and then we'll do some practice problems. All right, the symbol for parallel that you'll see is this. So if I want to say line AB is parallel to line CD, I would write this. So these are my 2 lines, and then I would put parallel lines right there. So the way you would read that is line AB is parallel to line CD. That's what the symbol is that we use for parallel. Now when you're looking at 2 lines, the way you can tell that these lines are parallel is they have little triangles on them like that match each other. So you could have them like that, or maybe you have 2. So that helps distinguish one set of parallel lines from another. We see 1 triangle on those 2 lines, that indicates they're parallel to each other. The other lines we see 2 triangles, that indicates that those 2 are parallel to each other. Right? And then a transversal is essentially just a line that is crossing at least 2 other lines. That's the definition for a transversal. Okay, so then down here, just so you know, a couple shortcuts that you can be aware of are angles are either equal or add up to 180, is what we talked about before. They're either congruent or supplemental. And once you're given one angle, you should be able to find all of them, okay? And as I said earlier, same side, interior and linear pairs are the only ones that add up to 180. All the other ones should be congruent to each other. Okay, so let's practice this, practice using this with some actual algebra. All right, so this first problem right here, we've got this situation where we got two parallel lines and a transversal is going through them. So let's look at the angles right here and identify the relationship or solve for x. Okay, so this one says solve for x. Some of them will do it, just wants us to find the relationship. So a trick that you can use on these is to start in the upper left, okay, up here, and label each angle with the letter A or letter B. All right, so there's going to be a total of 8 angles. Always remember that when you've got just 2 lines and one transversal, that's going to make 8 angles, 4 angles at each intersection. So that'll help you be aware of how many letters you should put. So we should put 8 letters right here because there's 8 different angles. So I'm going to start in the upper left, I'm going to put an A, and I'm going to alternate A, B, A, B, A, B, A, B. So the next angle down, I put a B, and then the next angle, I put an A, the next angle, I put a B. So there's 4 of them. Now I'm going to go back up the other side. Okay, don't go down the other side. You're going to go down one side and then back up the other. So I went A, B, A, B. Now go back up, A, B, A, B. So once you do that, if you do it right, then all the angles that are A's are going to be equal to each other. All the angles that are labeled with B's are going to be equal to each other. And angles that are A and B are going to be supplemental or supplementary. They'll add up to be 180. Okay, so looking at this one, we see that 130 is A and 19x minus 3 is A. So since they both have an A, that helps me know that they're equal to each other. So that's how I'm going to set up my equation. I'm going to say 19x minus 3 equals 130. And I can solve, add 3. So I get 19x equals 133. And then I'm going to take 133 and I'll divide it by 19. So whenever you divide 133 by 19, you should get 7. So x equals 7. Now, does the question say to find x or find an angle? Oh, it says find x, so that's my answer. X equals 7. All right, let's do one more, and I'll let you guys practice a couple. So for number 2, let's start with our AB. Upper left, let's put A. The next angle, put a B. Next angle A, next one B. And then let's go back up the other side. A, B, A, B. All right, so right here, both of the expressions we're looking at are B's, which means they're equal. So we'll say 110 plus X equals 100. And we'll solve minus 110 minus 110. So X is going to equal 100 minus 110, which is negative 10. And again, X can be negative, that's okay. All right, so go ahead and pause the video. See if you can try 3 and 4. Remember to do the AB thing. And you should get 8 total A's and B's. All right, if you put your A's and B's and you don't have 8 of them total, then you must have done something wrong. Go back and make sure you didn't skip an angle. All right, so give it a try, pause it, and then let me know if you have any questions. Okay, so for number 3, you can see we labeled it AB's, and both of them ended up being A's, so they should be equal. So we set them equal to each other, add 1, and then divide by 36, and you get x equals 3 for number 3. And number 4, we label AB. Both of them should be B's. So then again, we set them equal, and then right here, this equation can be a little tricky. Best thing to do is subtract 6x, all right, because we don't want to move the 5x and leave nothing over there on the right side. If you do that, you got to make sure you put a 0 over there as a placeholder. You can't just leave nothing over there. So subtracting 6x is the easiest way to do it. And then it leaves negative x, so we got to divide by negative 1 in order to get x by itself. We divide by negative 1 to get x equals 10. Now, all of these ended up being equal. What you would do, though, let's say one of them had 5x right here. All right, so instead of it being right here, it's over there with A. So if you get a problem like this and one of the expressions is A and the other is B, then you need to set up your equation like this. Add 5x plus 6x minus 10 equals 180. Because remember, now they're not equal to each other, they're supplemental. They're going to add up to be 180. So if you get one as an A and one as a B, add the two expressions to equal 180 and then solve. So those are the two situations you'll get. They'll either be equal or you'll want to add them to equal 180. All right, so now let's look at these next couple problems. Right here, all we're going to do is identify the relationship. So we're going to say, are they vertical angles, alternate interior, whatever. Okay, so look at number 5. Y and X. They're both on the interior, so I know they're going to be something interior angles. All right, they're on the alternate side of the transversal. So we'd say alternate interior angles. All right, number 6. Okay, these are, one's on the outside and one's on the inside, so they're not exterior or interior. But notice this is in the top left and this one's in the top left of its intersection. So these are corresponding. Okay, they're corresponding because they're in the same location at their respective intersections. So I'm going to pause it, let you guys see if you can identify the relationship between number 7 and number 8. Okay, number 7 are same side interior angles because they're on the same side of the transversal. Notice they're both on this side right here, and they're also both on the interior. So they're same side interior angles. Number 8, well, these two are opposite each other, right? They're on opposite sides. So these are vertical angles. Okay? All right, a couple of other kinds of questions you might have to answer on these that can be a little tricky. It says find the value of x that makes lines U and V parallel. So right here, we don't know that these are parallel lines. We want to find what x would have to be in order to show that they're parallel. So if these were parallel, to make these parallel, this angle and this angle right here have to be either congruent or supplemental. We need to figure out what they got to be, and to that we'll do the AB thing. AB, AB, and then AB, AB. Okay, so one of them is an A and the other is a B. That means they should add up to 180 to make the lines parallel. So we're going to add them up, 9x minus 7 plus 13x plus 11 to equal 180. In order for those two to be parallel, those two angles got to be supplemental. So now we combine 9x and 13x into 22x. Minus 7 and 11 is 4. So we subtract 4. That leaves 22x. And 180 minus 4 is 176. All right, then the last step we've got to do is take 22x and divide it by 22. Of course, we divide 176 by 22. And 176 divided by 22 gives us 8. So x would have to be 8. If it says find the value of x that makes lines U and V parallel. If x is 8, then we know that the two lines U and V are parallel. All right, number 10. Do the same thing. AB, 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 AB. Okay, so both expressions this time are A's, which means they should be equal in order to make the lines parallel. So I'm going to subtract 6x. That leaves 2x minus 2 equals 16. Then I'll add 2. So 2x equals 18. Once I divide 2, I get x equals 9. So x has to equal 9 in order for lines U and V to be parallel. Go ahead and pause the video, give the last two a try, and then we'll practice some. Alright, so as you can see here, we labeled it A or B's. Both of the expressions were B's, so we set them equal. When we set them equal, we need to subtract 11x. We get negative 1x, divide by negative 1, so x equals 12. Then over here on number 12, same thing. They should be equal, so we set them equal to each other. Subtract 58 to get x by itself, and we get x equals negative 8. All right, let me know if you guys have any questions on this. If you don't, then let's go ahead and start practicing.